Welcome back to Josh Does Math. In this video we're going to be working with the normal to a curve. So here's the problem. The line through a point on a curve which is perpendicular to the tangent at that point is called the normal to the curve at that point. Find the normal to the curve 4y plus x squared equals 5 at the point 1, 1. So before I even do anything, I'm going to get this equation into y is equal to something form because that will allow me to kind of visualize what's going on better. So there we go. Y is equal to 5 minus x squared over 4. So that's going to be a parabola that's going to open downward. So I'll just draw it like this, and we're looking at some point on it 1, 1. So obviously I didn't draw the parabola completely correctly here. But at some point, I'll just shift it over and make it x equals 1 or somewhere around there. We're looking for the equation of the normal to the curve, which is perpendicular to the tangent to the curve. So let's just say at this point right here, what is the tangent to the curve? Well, it's going to be this line like that. So what would be the normal to the curve? Well, it's going to be that line like that. So our goal is to find the equation of the normal. Well, how do we do that? Well, if we come up with some equation for any line, it needs a slope. So what is the slope of this normal going to be? Well, we can find that by looking at the derivative at x equals 1. So here's our equation right here. I'm going to split it up just because this will be a little easier in the future if we do 5 over 4 minus x squared over 4. So we're looking at the derivative of this. dy dx is equal to derivative of the first term, it's constant, so it's 0. Derivative of the second term, power out front, 1 smaller on the power. It's going to be negative 2x over 4, which is just negative x over 2. That's my derivative. Now the question is, what is my derivative at x equals 1? Well, I'll just plug in x equals 1. dy dx at x equals 1 is going to be negative 1/2. So that's the slope of the tangent at x equals 1. Now, what is the slope of the normal at x equals 1? Well, if you have two perpendicular lines, you know that their slopes are opposite reciprocals of each other. So this is the tangent right here. So the normal will have a slope that is the opposite reciprocal of negative 1/2. So flip the fraction and flip the sign, and you get just 2. So our normal is going to have a slope of 2. All right. What else do we know about this normal line? Well, we know it goes through the point 1, 1. So I have a point, I have a slope. That means I can use point slope form to easily figure out the equation of the line. So point slope form says y2 minus y1 is equal to m times x2 minus x1, where x1, y1 is some point on the line, and x2, y2 is some other point on the line. So for this line right here, I'm going to pick this point, 1, 1, to be one of my points, and I'll pick my other point to be just some x, y. That way, whenever I plug in some numbers to this equation, I'll still be left with x, y. So I'll be left with an x and a y in this equation, and that's going to be the equation of the line in terms of x and y. So I'll say that y2 and x2 are going to be y and x. And I'll say that y1 and x1 are just going to be that point I'm given, 1, 1. So I'm plugging in a 1 and plugging in a 1 right there. And what's the slope? As we said, it was 2. Well, all that's left is solve for y and maybe put it in y equals mx plus b form. Just simplify it a little bit. So we'll say y minus 1 is equal to 2x minus 2. Now I'm going to add 1 to each side. So I get y is equal to 2x minus 1. So that is the equation of the normal at the point 1, 1. So all I did was first look at the tangent, and I did that by taking the derivative, and then I related the tangent to the normal, and I was able to find the equation of the normal at the point 1, 1. Thanks for watching.